Welcome to Physics 30 Prep Fast Track, Lesson 2-3. We'll look at how to calculate net force when we're dealing with both friction and dealing with gravity. So, if an object is being influenced by forces, it's the net or unbalanced force that causes the acceleration. This is, of course, according to Newton's second law. So after a force is applied, the net force is most often influenced by two other forces. One is friction, and the other one is gravity. Now, generally, if you're lifting an object, the applied force, let's say 8 newtons of your hand, might be pushing up. And, of course, if the weight of the object is 5 newtons, then the force acting down is going to be 5. So you have an upward force of 8, a downward force of 5. When you add these two forces together, you get a net force of course, 3 newtons. Because the upward force is greater than the downward force, the net force is up. All right, so in this case, the net force is 3 newtons up, and the object will accelerate upward, of course, based on Newton's second law. Depending on the mass of the object, you will have an upward acceleration. All right, now, that's lifting an object. And of course, when you lift against the force of gravity. When you slide an object across a table, you're not sliding the object against the force of gravity, you're sliding it against the force of friction. So, generally, vertically we deal with gravity, and horizontally we have to contend with friction. We ignore the air friction vertically, and so gravity is the opposing force vertically, and friction is the opposing force horizontally. So if you're pushing an object horizontally, gravity is not a factor, but friction often is. Let's say we did the same scenario. Let's say we applied with a force of 8 newtons to the right, and yet because of the interaction between the two surfaces, let's say a book sliding against a table, there is a force of 5 newtons that opposes your motion, and so we would say that the frictional force is negative 5. When you add these two as vectors, notice the 8 newtons to the right plus the 5 newtons to the left, you end up with a net force. All right, F net is the sum of all forces. The applied force plus frictional force gives you a net force of 3 newtons, and the object would have a net force to the right, and therefore an acceleration to the right. All right, and that's how we deal with calculating net force using either considering either the force of gravity that we contend with or the force of friction that we contend with. And of course, once we've determined the net force, then we can use Newton's second law and, of course, all of the kinematic expressions to solve for any of these unknowns: initial, final, displacement, time, and even acceleration. We'll look at some sample problems that require determining the net force in order to solve these kinematic problems. All right? So example number 1, it says a horizontal force of 20 newtons is applied on a crate with a mass of 20 kilograms. If the crate is initially at rest and the force of friction between the block and the floor is 120, what is the net force? Now, you should be able to work through these fairly easily. I'll just give you a few clues on this. Of course, the net force is going to be what? 200 newtons is the applied force. 120 newtons is the opposing force, in this case the force of friction. And therefore, the net force is going to be 200 plus negative 120, and 200 plus negative 120 gives you 80 newtons. Now, the acceleration is going to be found by using Newton's second law. If the net force is 80, and you divide that by the mass, all right, because A is equal to F net over M, then net force of 80 divided by the mass of 20 will give you an an acceleration of 4. And then, of course, the final speed after 3 seconds. Well, I'll leave this one with you. The final speed is going to be, of course, found by using one of your kinematic expressions. Since you know the initial velocity is 0, all right, it says right here, at rest, and the acceleration is, now you figured out that it's 4, and you also know that the time is 3 seconds, you should be able to find an equation that helps you to solve for final speed or final velocity, and that will be 12 meters per second. All right, so this one should be straightforward. These are just examples for you. The next example, of course, similar to this, a book with a mass of 3 kilograms is lifted with a force of 50 newtons. Now, you know that the upward force is 50 newtons. Now, what about the downward force? In this case, the downward force is found by finding the weight of the object. And the weight of the object is found by taking the mass of the object and multiplying by 9.01. The force of gravity is equal to mg. And so that would be 3 kilograms times 9.81 meters per second squared. And you get, of course, 29.43 newtons. So we have our net force, all right, because, of course, it's being lifted up with a force of 50, and the downward force of 29 newtons is going to oppose that. And so you can find out the net force is basically positive 50 plus negative 29.43. Once you know that, of course, 50 plus negative 29.43 will give you a result of 20.6 newtons. Once you know the net force, then what do? Well, then you can calculate the acceleration, because, of course, you can use acceleration is equal to the net force divided by the mass. And, of course, you know the mass is 3 kilograms. You know the net force is 20.6. And then, of course, once you know the net force, then you can calculate the final velocity of the book after 4 meters by using kinematics. So this is a bit of a tough question, but the steps that you take to go through this should give you the answers that are given at the bottom here. Another example, this is sometimes called an Atwood pulley, but you have a 3 kilogram cart that is attached as shown to a hanging 1.2 kilogram mass. The system is initially at rest, and the frictional force between the cart and the table is 4 newtons. Now, this involves a little bit of work to calculate all of the components. The first thing you would need is the net force. Well, the net force is going to be the force that's acting on this mass. There is no force acting on the 3 kilogram by itself. It's the only force that's acting on it is the force that's being applied by the cable. And the force on the cable is supplied by this 1.2 kilogram mass. So the first thing you would do is figure out what the force of gravity is on the 1.2 kilogram mass. And of course that would be force of gravity is equal to mg, which is of course 1.2 kilograms times 9.81. And that gives you 11.772 newtons. Now, of course, they also tell us that there's a force of friction of 4 newtons. And, of course, that means that the net force is going to be 7.772 newtons, or as we mentioned above, 7.8 newtons. And now that we have the net force acting on the system, we can calculate the acceleration of the system. Now, one thing with this type of problem that you also have to consider is that the force is not only acting on the 1.2 kilogram mass, but it's also acting on the 3. So the acceleration needs to be, acceleration is equal to the F net divided by mass, but it's going to be 7.772 divided by the total mass of the system, which is 4.2 kilograms. And that's where we get our result. The result is 1.85 meters per second squared, and of course that rounds to 1.9. So now that we have the acceleration and the net force, we can calculate the final speed after a given time using kinematics. You should get 2.8 meters per second as the final speed after that period of time. So example number 4, again, a truck with a total mass of 4,000 kilograms is initially moving at 15 along a level road. He steps on the brakes and stops in 25 meters. Now, to find the acceleration, we would just use kinematics. The truck has a total mass of 4,000. The fact is that it's moving at 15 meters per second. That's the initial velocity. And so we have the initial velocity here. Of course, it stops. That means what? That means the final velocity is 0. So we have initial velocity here. We have final velocity here. And it takes 25 meters. So we have VI, VF, D, and we can easily use kinematics to calculate A. You start with the VF squared is equal to VI squared plus 2AD. Now that we have the acceleration, the net force is just, of course, equal to what? Mass times acceleration. Since you know the acceleration, your calculation would be 45 or 4.5 meters per second squared, and you multiply that by the mass of the object, and you should get 18,000 newtons, or in other words, 18 kilonewtons. And of course, a kilonewton is just 1,000 newtons. And the reason it's negative is because in both cases, what's it doing to the object? It's causing the object to slow down. All right, so those are some basic examples, and you'll see lots of these when you do your practice sessions, but these are a few that you can work on. And this Atwood kind of question, number 3, is a fairly high level kind of question.